classes, we have discussed the molecular formula and the empirical formula. That is, the molecular formula represents the exact number of different kinds of atom in a molecule, whereas empirical formula represents the simplest whole number ratio of different kinds of atom in a molecule. And we have discussed it. But let us make it more clear by taking some example. What we have the molecular formula. What is that one? The molecular formula represents the exact number of different kinds of atom in a molecule. Whereas we have discussed what? The empirical formula. What is that one? We had discussed that an empirical formula represents the simple whole number ratio of different kinds of atom in a molecule. Let us understand by taking an example. For example, if we take glucose, then its molecular formula of glucose is it is C6H12O6. It shows the exact number of different kinds of atom. It means the glucose contains 6 carbon atom together with 12 hydrogen atom and 6 oxygen atom. It means the molecular formula represents the exact number of different kinds of atom in a molecule. But what about the empirical formula? Let us discuss the empirical formula of glucose. Empirical formula of glucose. You know what is its molecular formula? It is C6H12O6. But here in empirical formula, we represent the simple whole number ratio. If we simplify it, what we have? 6 1 ja 6, 6 2 ja 12, and 6 1 ja 6. It means the empirical formula of glucose is C1H2O1. This is the relation of empirical and molecular formula. Let us take another example. That the molecular formula Molecular formula of hydrogen peroxide. It is H2O2. That means it is going to represent the exact number of different kinds of atom in a molecule. But what is the empirical formula? Empirical formula of hydrogen peroxide. It is what we have? H2O2. When we simplified it, what is so? It's so H1O1. Or we can simply say HO. This is all about the molecular formula and empirical formula. Let us discuss the next topic, that is cytometry and cytometric calculation. As the name indicates, cytometry. Cytion means a Greek word. Cytion means the element, and metry means in measured amount. It means the cytometric deals with the masses of various kinds of reactant and product in a chemical reaction. It means the cytometric deals with the calculation of masses and sometimes volumes of various reactant and product in a chemical reaction. Let us discuss it. We'll discuss cytometric and cytometric calculation. As the name indicates, what cytometric? Cyton, it means, cytometric means it has a Greek word, that is cytion, it means element, and metry, it means measured amount. What it means? It means cytometric deals with the calculation of masses and sometimes volume. Cytometric deals with the calculation of masses of various kinds of reactant and product in a chemical reaction. In order to know what the cytometric says, in order to deal with the calculation involving in a chemical reaction, first of all, we have to balance our chemical equation. The first step to deal with the calculation involving mass of reactant and product, we have to balance the chemical reaction. We have to balance the chemical reaction, right? It means, let us have a reaction, that is the combustion of methane. It means methane burn in the presence of oxygen to produce, we know, carbon dioxide plus water. The first condition to deal with the chemical equation involving the masses of reactant and product, first of all, we have to balance the chemical equation. Carbon 1, hydrogen 4, hydrogen 2. Then we have to balance it. What we see? Carbon 1, hydrogen 4, here hydrogen 4, oxygen 2. Then what we have, the number of oxygen, that is 2 and 2, 4. It means 2O2. In this way, we have balanced the chemical equation. What the information we obtain from this chemical equation, we will discuss. What we have the chemical reaction is that methane burns in the presence of oxygen to give what? Carbon dioxide plus water. So we mention their state, that is in gas state. This one is in gas state. This one is in gas state. This one also in gas state. We will balance it, and we have already balanced it. Just like this. 1 carbon, 4 hydrogen, we have 4 hydrogen. 2 and 2, 4 oxygen, we have 4 oxygen. What information which we obtain from this chemical equation? You know, these are termed as reactant, and these are termed as product. The information which we obtain from this balanced chemical equation what we have, let us see. The first information which we got, what we see, the cytometric coefficient of methane is 1. The cytometric coefficient of oxygen is 2. The cytometric coefficient of carbon dioxide is 1. And the cytometric coefficient of water is 2. What it means? It means 1 mole of methane or 1 molecule of methane combined with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water. The first information which we obtain is that 1 molecule of methane combined with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of 2 molecule of water. So the next we will discuss was the mass of methane 12 plus 4 16 gram. The masses of oxygen, atomic mass is 16 to the 32, 32 into 2, that is 64 gram. What is the amount of carbon dioxide produced here? It is 12 plus 32, that is 44 gram. And the amount of water here is 2 plus 16, 18 to the 36 gram. It means when we are going to relate their masses of reactant and product, what we have? We have when 12 plus 4, 16 gram of carbon dioxide react with, it is this 32 into 2, that is atomic mass of oxygen is 16 to the 32, molecular mass into 2, that is 64, combines with 64 gram of oxygen then it produces what is 12, 32 plus 12, that is 44 gram of carbon dioxide and we have 18 to the 36 gram of water. We have the another relation in relation to moles. What we see, when 1 mole of methane react with 2 mole molecule of oxygen, then it will produce 1 mole molecule of carbon dioxide and 2 mole molecule of water. What we have? The third one, when 1 mole molecule of methane react with what? 2 mole molecule of oxygen, it produces 1 mole molecule of carbon dioxide and 2 mole molecule of water. What we produce? That is 2 mole. To the next, we see here all the reactants and product are in gaseous state. Then we have also a relation in volume. That is, we know that at STP, 1 mole of any gases occupied 22.7 liter of volume. It means what we have? 1 mole of methane. That means it is 22.7 liter. 2 molecule of oxygen, that is 22.7 into 2, that is 45.4 liter of oxygen to give 22.7 liter of carbon dioxide and 45.4 liter of water. Fourth point is that 22.7 liter of methane is bond in the presence of 45.4 liters of oxygen, then it produces what? 22.7 liter of carbon dioxide and what? And 45.4 liter of water vapor. This is how we are going to relate what? We are going to relate moles with mass with volume. It means we are going to relate the number of moles, mass and volume together with the number of molecules. How to relate the volume with mass? We have the relation that density is equals to mass by volume. This is the relation. What we obtain is that, first of all, during cytometric calculation, we have to produce the balanced chemical equation. And what the information we obtain from the balanced chemical equation is that we have the relation, we have the cytometric coefficient which will relate the reactant with the product, amount of reactant with the amount of product. We have discussed in this case 1 mole of methane react with 2 mole of oxygen to produce 1 mole of carbon dioxide, 2 mole of water. Here it is exothermic reaction, that's why water is in gas state. The next we have the relation. This is what? 16 gram of carbon dioxide react with 64 gram of oxygen. Then it produces 44 gram of carbon dioxide and 36 gram of water. The same relation related with the cytometric coefficient. To the next, if we relate the volume, we know that 1 mole of gases at STP occupies 22.7 liter and 22.7 liter